Welcome students, in this video we will learn derivative using product rule and quotient rule. What is product rule? According to the definition, if two functions are multiplying and they are differentiable, then the formula derivative of two functions, which will be the first function as it is and derivative of second function plus second function as it is and the derivative of first function. Let's use this in some examples. Here is a function in which two functions are multiplying. First is considered as f of x and second considered as g of x. Using product rule, we'll apply the derivative on both sides, d by dx on the right side and the left hand side. Now on the right side, we use the formula first function as it is, so 4x squared minus 1 as it is, and the derivative of second function 7x cubed plus x. Now the second function 7x cubed plus x as it is and the first function derivative. So right now we just put the derivative with the functions. So here we will apply the derivative formulas. So if you notice that here is 7x cubed plus x. So 7 is the constant which will be as it is, and we apply the power rule on x cubed, which will be 3x squared, and the derivative of x is 1. And now the second function as it is, and derivative of this function will be 4 as it is, and apply the power rule on x squared, which will be 2x minus 1, derivative is 0. Now we need to simplify 4x squared minus 1, and 7 times 3 is 21x squared plus 1. Here will be 8x. It's time to simplify and we'll multiply the both factors. Combine the terms with x power 4 and x squared and the constant minus 1. This is the final answer. Example number 2. Here we have the function of s in the form of t. So we find the derivative of function of s with respect to t. So it would be ds by dt. Same apply the derivative with respect to t on both sides. And on the right side, we can see that two functions are multiplying. So we use the product rule where first function as it is and derivative of second function plus second function as it is and write the derivative of first function. And next is we need to apply the derivative of square root of t. Square root of t means t raised to power 1 by 2. So use the power rule. Power will be 4. 1 half, 1 minus from the power 1 by 2 minus 1. And same on the second part, square root t as it is, and the derivative of 1 plus t will be 0 plus 1. Because we are taking the derivative with respect to t, so derivative of t would be 1. And now it's time to simplify. And here we can take the LCM on both sides. And after taking the LCM, you will notice that we have 1 plus t and 2 square root of t will multiply with the square root of t. It will be 2 times square root of t, and which becomes 2 square root of t square. And after simplification, you will have 1 plus 3t over 2 square root of t. That is your answer. What is the quotient rule? According to the definition, if two functions are dividing such that the denominator function should not be equal to 0, because you know that if denominator will be 0, it becomes undefined. So denominator should not be 0. And you have any two functions, then we use the formula. According to the formula, whatever the function is on below denominator, it will be as it is first, and then take the derivative of the first function minus now first function as it is, like a first function means above function, numerator. It will be as it is, and take the derivative of below function, denominator function. And on the denominator, it always be the square of the function which is on the denominator. So let's use this formula in some examples. Here we have an example in which we have to take y dash. Y dash means the derivative. So if you notice that we have two functions and they are dividing, so we use the quotient rule. And in the quotient rule, numerator function considered as f of x and denominator considered as g of x. And we have this function. Apply the derivative with respect to x on both sides. After taking the derivative, apply the formula, and according to the formula, denominator function will be in the form of square, so x plus 5 square, and same this function comes on the numerator as it is. Take the derivative of numerator function, so d by dx of above function, which is x cube plus 2x square minus 1, and then the above function as it is, and the derivative of below function, which is x plus 5. It's time to take the derivatives of these functions, so x plus 5 as it is, and derivative of this using power rule. Derivative has 3x square plus 2 is constant, and derivative x square will be 2x, and the 1 is constant, so derivative 0. In the second part, x cube plus 2x square minus 1 as it is, and derivative of this will be 1 plus 0, and denominator function will be as it is, of course. And now it's time to simplify, so x times 3x square will be 3x cube, 4x square, and 15x square, and this will be 20x. Q minus multiply inside with every term, so change the signs, and denominator term as it is. Now combine the like terms, so x cube term will be combined with x cube, and x square term will be combined with x square. And after simplifying, you will have this. This is the final answer. Here is another example which can be solved by using quotient rule. There is no hard and fast rule, so you can try it by using the same formula. This is an example. Sometimes we have given the question like this. So how could we solve if we have to find the derivative of function at some value and there is no function is given? So all we have to do is we will plug the value after taking the derivative. In the first part, f of x is equal to 2f of x minus 3g of x. All we have to do is we need to find f dash of 1. So first we have to take the derivative. It's obvious. So let's take the derivative. When we apply the derivative on both sides, f dash of x will be, the constant will be as it is, and derivative of the functions. And now it's time to find f dash of 1. So plug x is equal to 1 in each value. You have this function. According to the given condition, f dash of 1 and g dash of 1 is given, which is 2 and negative 1. So plug it here and you will have 4 plus 3, which is 7. That is your answer. Same in the b part. Take the derivative on both sides. And here you can see that we have the function in the form of square. So we use the power rule. And what is the power rule? That take the power before from the function and 1 subtract from the power, which will be 1 power left. Further, you have to take the derivative of inside function, which will be f dash of x. So now simplify to f of x and f dash of x, and as we have to find the value at 1, so plug x is equal to 1, f dash of x is equal to 2 times f of 1 and f dash of 1. Plug the values of these terms, you will have negative 4. This is your answer. Now in the C part, you can see that the functions are multiplying. We use the product rule, and according to the product rule, first function as it is and derivative of second function. So it will be g dash of x plus second function as it is and derivative of first function, which is f dash of x. And now plug x is equal to 1. And plugging the values, you will have f dash of 1 equals 1 plus 6, that is equals to 7. And on the D part, you can see the functions are dividing, so we use the quotient rule. And according to the quotient rule, you know that the denominator function as it is with the square and same denominator function above, and derivative of numerator function, which is f dash of x, minus the first function numerator function as it is and derivative of denominator function, which is g dash of x. And now plug x is equal to 1 in the formula and plugging the given values into the function and simplifying, you have 5 by 9. This is your answer. How to solve this type of question? You can see that the functions are dividing, we can use the quotient rule, but in the numerator two functions all multiplying as well. So we use the product rule and quotient rule both, but for this we need to rearrange this. So I separate 2 square root of x plus 1 as a separate function as first function, and the second function will be as x minus 1 and x plus 3, so that it can be easily solved by taking two functions, and we can use the product rule here. According to the product rule, first function and second function we consider, and first function as it is, and take the derivative of second function plus the second function as it is, and d by dx of the first function. Now what is d by dx of this function? So if you notice, these two functions are dividing, so we use the quotient rule here. So according to the quotient rule, denominator function will be in the form of square, and the same function will be above, and the derivative of numerator function, x derivative 1 and 1 derivative is 0. The numerator function as it is, x minus 1, and the derivative of x plus 3, which will be 1 plus 0, and plus the second function x minus 1 over x plus 3 as it is, and derivative of this inside function 2 is a constant as it is, and the derivative of square root of x will be 1 minus power, which will be negative 1 by 2, and the derivative of 1 is constant, which is 0. Now it's time to simplify. And this 2 and 2 is cancelled, left 1 over square root of x. And now to simplify, you have x cancelled and it will be 4 over x plus 3 square. And on the right side, the denominator will be multiplied with the denominator term. More simplifying, we will take the LCM. So we have denominator with x plus 3 square, and there is one more term in the denominator which is square root of x. And on the first term, the square root of x is not on the denominator, so it multiply with the above term. So it will be 8 square root of x plus 4. And same on the right side, you have x plus 3 and square root of x, but there is x plus 3 square on the denominator, so which will be multiply with the numerator term. And now it's time to simplify. After simplifying, you will combine the like terms, so all x terms will be combined and x square term as it is, and the rest is 4 square root of x minus 3 and denominator term as it is. Now we cannot simplify it further, so this is your final answer. This is the whole solution of the question. Here is another type of question in which you can see that there are three functions are multiplying. So how can we use product rule formula for three functions? So for this, we'll consider two functions and multiply them, so that after multiplying two functions, you will left with the two functions, and then we can easily apply the product rule. First of all, multiply the first two factors, and after multiplying, you will have 2x, and the 2 plus 1 will be 3 plus 1 by x, which can be write as x power negative 1. And the second factor as it is. Now you have two factors and you can easily apply the product rule, and you are well aware of this, that first function as it is, derivative of second function plus second function as it is, and derivative of the first function. And now it's time to simplify. So 2 times minus 3 is minus 6, and x power 1 minus 4, because first x has 1 and second x has minus 4 power. So we combine the both powers. Similarly, now 3 times minus 3 is minus 9 and x power minus 4. And now the third term x power minus 1 combined with x power minus 4. So minus 3 times minus 1 minus 4. And same we multiply the second term. So x power minus 3 times 2 is 2, x power minus 3. And this will be multiplied, it will be negative 1 x power minus 3 minus 2, and 7 multiplied with both terms, you have 14 minus 7 x power minus 2. And now we need to simplify the powers. Now we need to combine the like terms. So minus 5 power combined with minus 5 and minus 3 power combined with minus 3. So after simplification, we'll have minus 4x power minus 3 and minus 9x raised to the power minus 4 minus 4x raised to the power minus 3 and minus 7x raised to the power minus 2 and plus 14. And now you can see that we have negative power. We can take it on the denominator to make the power positive. And then we can take the LCMs. Highest power will be on the denominator. First have the same denominator, so minus 4 as it is. Second have x power 4, so 1x multiplied with 9. Next has x power 3, so 2x multiplied with 4. Next has x squared, so 3x multiplied with 7. And same for 14, there is no denominator, so x5 multiplied with x power 5. And now we rearrange it. This is your final answer. Thank you so much for watching. Please subscribe my channel for more videos.